Hey everybody, this is Larry. This is day 30th of the June daily Leetcode daily challenge. Uh, Hit the like button, hit the subscribe button. Hope you had a great month. I've been doing this the last 90 days and I'm going to keep doing it for July, I think. So definitely hit the subscribe button if you enjoy it. Come to Discord, come ask questions like this one, and we'll do it together. All right, let's get started. Research 2. So research 2 is that you're giving a board, almost like a Boggle board or something, like that's the game that is familiar with. And you have a set of you have a dictionary with a set of words. You're trying to figure out in the board what words are on the board, right? So for me, this is a little bit of a straightforward problem. How you would do it is by there's a lot of well-studied literature on a similar problem, either this or variations of it. But the short answer is that it's very computationally hard. And just knowing that allowed me to not try to look for anything too clever. The unfortunate part about this particular problem on Leetcode is that they don't give you the constraints of the input. So it's a little hard to guess whether, like, there's a little bit of mind reading where you have to figure out, do you have to be smarter, right? And if you're in an interview context, ask the interviewer, be like, hey, I think this is like a computationally hard problem. Do I know? I'm going to try to backtrack or something like that and then see if your interviewer will, is that what they're looking for, right? And yeah, and that's pretty much how I'm going to solve this problem with backtracking and your favorite data structure, a try. So anytime, my thing is that anytime you're giving a dictionary where you do something with a prefix, try is going to come up. Or at least, like I would like to think about, I mean, it might not always require a try, but it is the thing that I'll be like, okay, is it a try though? And at least ask yourself that question. So I'm not going to get into the try too much because there's a lot of literature on it. I don't want to dwell on that part. I want to, explain how I use that to solve this problem. But basically, given a try of the dictionary where you have the root node and each edge is a character in the transition, and you just keep track of where the nodes, where the words end by marking that node as, well, being the end of a word, which I have in the diagram by drawing them pink. And basically what you try to do is keep track step by step, one with another. If I move one character, or if I register or recognize one character on the Boggle board, you also move one step down or one edge down on the try. For example, let's say you created this try and of these words, and you start at the node O, right? Well, is the character O, or rather, is there an edge from the root node that has the O edge? And the answer is yes, because, well, if you create a try, O is in there, right? And then now maybe you would try to go down, and going down, you'll be like, well, is there now a Y in the edge? And the answer is no, because there's no OE word, and that's how a try works as you go down. And because you're moving one step at a time on the Boggle board or the game board, and you're also moving one step at a time on a try. And if you mark the end of the word on the try as a possible end of the word, all you have to do is just add the word to the dictionary when that happens. And that's backtracking. And I'm gonna go over it with the code pretty soon, but that's kind of the idea that I came up with as I was solving it. There are many ways to do your node class and your try class. This is just my way of doing it, and I do this live, so if you stay after the explanation, you'll get to watch me solve it live, and you could see my live thought processes. Though, to be honest, for this problem, it's a relatively standard problem, or at least it's a problem that is known, so I didn't really think about anything other than this solution. But anyway, for my node class, I just have the standard a node thing of, okay, does it have an edge? Can I create an edge, or create a node with an edge of that value? And is it at the end, or can we set this to be an end of a word, right? And then the try class for me is also a symbol. I just keep it that for every word that we add to the try, for every character of the word, we just create an edge, create an edge, create an edge, create an edge, and then at the very end, just set, make sure that we set that as the end, right? And because we don't always create a node, this will allow us to kind of parallel problems together, if you will. And what I mean by that is that, let's say there's oath and oath, then when you go OANT, then in essence you're doing two words at the same time. So this allows you to take advantage of that. And the other thing that it lets you take advantage of is that after OANT, you don't really try to go ye, because you know that no words begin with OATE, then you don't have to keep going, right? So that you could terminate early. So that's kind of how my backtracking is keep track of. I have a visited array. So for every word in a try, I insert it into for every word in a dictionary, I add it to the try, and then for every node, I created a visit array or a visited matrix so that I don't go to the same node twice. So by node, I mean the same cell, sorry. And you don't want to go to the same cell twice, otherwise you make up words, or I don't know, that's not in the dictionary, or you use more character, or you use fewer characters than you need. And the way that I implement it is just, if we already visited, we go back. Otherwise, we go up, down, left, right in this part of the code. I'm making sure that, of course, it's within the board. And if there's an edge there in the try, then we just go to the next node as part of the recursion. And we also just keep track of the characters that we've added along the way. And the thing that kicks us off is that we just, for every character in the board, we see, hey, can we use this first character to construct a string? And that's pretty much it. That's why this is a little bit tricky, because I usually go over the complexity right now, but the complexity is, it's backtracking, so it's going to be exponential in some form. But just knowing that means that you don't waste time trying to figure out a better solution. Though sometimes if the bounds are small enough, then maybe you could do dynamic programming, but that's another story. But given that unknown bounds, then in the general case, it's going to be some sort of backtracking or exhaustive search or something like that. And the best you can do is to, well, in the real world, you would maybe try to find some sort of approximation algorithm, or you try to find as much as you can things to prune the search tree so that you're able to terminate early. Like in this case, you know very quickly that there's no OAA words in the dictionary, so you don't even consider that part of the search tree, which is different than the try. But yeah, that's all I have for this problem. Let me know what you think. I hope you had a good month. Let me know how this problem treated you. And yeah, stay tuned for the live portion right about now. Hey, so this is the live portion of the video. Let's get started. Word search 2. Okay. Given a 2D board and a list of words in the dictionary, find all the words in the board. On the board, each word must be constructed from the letters of sequentially adjacent cell, where the adjacent cells are those horizontal or vertically neighboring. The same letter cell may not be used in more than one word. Okay. Wow, they have colors this one. That's fancy. I think this one's a little bit tricky because they don't tell you the bounds of the problem, because I'm pretty sure this is a very computationally hard problem, and I'm going to try to do it with backtracking, but yeah, I think what I'm going to do is, given these words in the dictionary, I'm gonna put it into a try, and then going to do backtracking from that, and then see if it gets anywhere. I don't know if I need to make another optimization, but that's what I'm going to start with. Also just thinking about how to do tries, or how do I want to do tries. Yeah, so I could just go with, yeah, I could write a class for it. And yeah, I have written this before, but for Leetcode, I like to just write them from scratch again. So yeah, just have a node root. Yeah, should be okay. Or value maybe. I like to use dollar signs for, though I think for the end character, but I think I've gotten burned by that before because for whatever reason dollar sign was in the string, but that's okay. Actually, I'll just use a hash table. Here should be get node. Okay. Something like that, and then I might add to it a little bit. I think that's what I need to go to start doing this problem. Yeah. So a word and words. Oh, actually, I guess I should declare this. Definitely need this. I have to make a distinction of something, but that's maybe okay. Maybe I just collections that default tick. Oh, because nope, forgot that I can't do it. Add to do. His value is not. I guess it's been a little bit rusty. Because I haven't restored the things on the edge, so that's okay. Let's just say it's true. been a while. I think this is not how I usually do it, but I think this is okay for now. So now for each character, that's the n is 0 true. This should be okay. Let's just print it out just to kind of gotta see how it goes. Ooh. Right. Let's set this. Oh, playing around with too many other languages lately. Forgot my Python. Oh, yeah, of course. Okay, but yeah, if you're uncertain about your code, obviously I recommend doing stuff like this so that you know, right now the code is very by itself, so that you know when you add things later, it's only going to be more complicated. Okay, so it's hard to tell if it works, but okay. And then now we can just do backtracking, I think. So yeah, let's start with notice. You go to try.root. Or maybe I don't need that actually. Let's actually set rows as you go to length of the board. Columns as you go to the length of the first string. Let's check that rows is equal to 0. Return just an empty list. I think is probably okay. Okay. And then now for row in range of rows. If contains edge, what I call it has edge. So this if the current node has this, then we start a recursion on this. Yeah. And this is where I'm thinking about whether I should use the global variable. I think I'm just going to abuse the global answer array for now. You could clean this up later, but I think I'm just optimizing for kind of getting it as fast as I can within reasonable readable code. But yeah, let's call it find. So we do want to keep for backtracking. We do want to keep and visited matrix. So let's just call it force times columns. Still don't like the syntax, but okay. Find words maybe, and then just return answer. So now let's write this recursive function. So now we have current row who arms visited array and try.root. Or just this is just a node. Actually, if we already visited this, then we return. If we haven't, then we will set this to visited. And because this is backtracking, we should reset afterwards. But then for now, let's go through. Let's make a thing with the directions, so that we can go up, down, left, right. guess technically this is dr for d row and d column. And the next row, you go to row plus dr. Now we just check that it is within, oops. Oh, just word. And what's the other thing? Now we look at our node. If node that has edge of upward of new row, new column, and then we find words of yeah, new row, new column, visit it again, and then node dot get, or also I think I have a, yeah, I needed to do, I think I need to move on from here because it parses the first character. Yep. Port of n row and call. And I have to get the next node. I think I have to keep track of where I've been. There are a couple of ways to do this. You could do it actually implicitly by keeping track of all the edges you go, but I'm just going to do something a little bit lazy. We'll see if it affects the performance, but yeah, I'm just going to go ongoing string maybe. It's a little bit long, but I think there's one more thing we have to do, which is to add the word to a list. So if we're at the end of a word, oh, I guess I could just do that. If we're at the end of the word, then we can add the word if node is and then end start append ongoing, something like that. All right, let's give it a go real quick. Okay, do I have to sort it or anything? Okay, I mean, this looks okay for now. Let's, I don't know, let's try something really dumb maybe. The thing with this is that it is computationally hard, so that it is possible that like the inputs may be really easy, because in a general case this is going to be ridiculous, right? Oops. Something like that, and you just have like basically this is, I mean, it's not the worst case, but it's the pretty bad case. So let's see how long that goes. Okay, still pretty fast, actually faster than expected. So let's just give it a go and then we'll see what happens. Though I should have maybe tested some non-existing case or something like that. But okay. Yeah, I wasn't sure if stuff like that mattered. I'm surprised that didn't come up on my other case. Yeah, why didn't that come up? But yeah, but we just have to dedupe it. That's not a big deal. But I'm surprised that this thing didn't come up here. Huh. Was that what I was kind of trying to test? Or maybe it did, I just didn't look at it. Oh yeah, it did actually. Okay, so I think I was just a little bit hasty. And also it came up here. So actually, okay. So I was just actually very wrong. It's just that I wasn't paying attention. That's totally my bad. But then now we just have to change this to a set, and I think we're okay. Except for at the very end, we change it back to a list. Just wasn't paying attention. Okay. Oh yeah, now it's insert or add instead. Okay, so that looks good still. Oh, this looks better now. I thought it used to tell you whether it matched, but maybe that's just the other interface, because Leetcode has a couple of interfaces, so maybe I get them confused. Okay, cool. Yeah, so other than a little bit of a misread, yeah. So what is the complexity for this problem? For these problems, it's actually kind of tricky to analyze because computationally it's actually ridiculous. Because you can just imagine that this gets really long and then you just keep on going, right? So really just, this is a backtracking algorithm. So it's going to be really tricky to kind of figure out the bounds usually. I mean, it is just exponential is the short answer. And you can definitely construct cases where it could be really, really bad. So yeah, so I think in general on an interview, people don't give backtracking as much anymore, but it still comes up from time to time. So I could definitely recommend practicing. The complexity analysis part is a little bit tricky, other than saying that it's expensive. And competitive programming, I think it doesn't really come up that much anymore because, well, you can't bound your things. So I mean, similar things might come up, but there'll be additional constraints such that you can be confident that your backtracking will run. So I haven't seen it as much recently because also it's not as interesting per se, because it is just brute force. But I could be wrong on that one. So let's see. Can you backtrack earlier? Okay, I didn't even do that, to be honest. Yeah, okay. So I think I did this not accidentally, just that didn't have to need a hint. Okay, cool. Yeah, that's all I have for this problem. Take a look at the code, I suppose. This is a long 68 lines of code. I have my this is just, it's not quite standard. I actually write it a little bit different every time because I don't commit myself to memorizing these classes. But this is my node class. It just contains things for holding an edge, a try for just adding words because we don't need to remove words in this case. And yeah, and then everything else is just backtracking. So I visit a node which is on row columns. I keep track, and then I remove it when I'm done, and I just keep going, and I just visit the try. Yeah, but I think a majority of this problem is just backtracking and understanding tries as an optimization, or so that you can know when to stop backtracking. And if you struggle with understanding what I'm doing, then definitely study up a little bit on try and also just backtracking, and depending on which one you feel like you're less comfortable with. And yeah, let me know what you think. Let me know what you think about today's farm and just this video in general. Leave a comment, hit the like button, hit the subscribe button, join the Discord, and I will see y'all tomorrow. Bye bye.